Okay, welcome to part 3 of our midterm review. We're on problem 16 here, and for this we're going to use this table here, this table of this summary table. And so let's see, this is survey. This data from a survey of total debt for college graduates, so excluding mortgages. So do college graduates have more variability in total debt than non-graduates? Can it be both? Explain using specific values. Okay, so the question is variability. And for variability, there are what measures can we look at here that give us indications of variability? Well, I made a little table here. Standard deviation is one of them, and range is one of them. Coefficient of variance is one of them. That would be the standard deviation over the mean. We don't see that number here, so it'd be the standard deviation over the mean. And the interquartile range, which is not given here, but it's it's given. What is given is the third quartile and the first quartile, so we can just subtract the first quartile from the third quartile, and we get. Okay, so now let's figure out what all these numbers are for graduates and non-graduates, comparing them, and we'll see if it looks like the graduates have more variability. Okay, for standard deviation, in other words, if this data were normal, it turns out the graduate data is normal. We have 4543 as the standard deviation, and for non-graduates it's 5011. So it looks like graduates are less variable, although this value is not really valid because we see that the kurtosis is less than -1. So this data is not normal, so that means that standard deviation is really not valid here. But anyway, but when we use that measure, the graduates are less variable. Okay, what's next? Range. We have the range here is 17,000 for graduates, and it's only 15,000 for non-graduates. And so in this case, for the range, we see that the non-graduates are less variable, or the graduates are more variable. Okay, so what's next? Coefficient of variance is another way to look at variability, and for coefficient of variance, we actually divide the standard deviation by its own mean, and we get a number variance value with respect to itself, and we see that for graduates that number is 23.23 variance, 23% variance, and for non-graduates it's 35% variance. Okay, so coefficient of variance. So it looks like non-graduates vary much more with respect to themselves, with respect to their mean as graduates. So graduates are less variable. The last one is we can look at the interquartile range, which is really the one you would look at if the data is not normal. And for graduates we have 7,180, and for non-graduates we have 10,418. So we see in this case the graduates are less variable. So it looks like 3 to 1. So what do we decide here? I think we can say that graduates are less variable. To explain the range may be high because of an outlier of non-graduates. I think this logic is wrong here, because an outlier, it should be an outlier of graduates in graduates. So there could be an outlier. The non-graduates doesn't look normal because the kurtosis is below 1 and the sample size is There's only 10. So this is an explanation for this being more variable instead of less variable. Really, the telling number, though, is because the data is not normal, we would look at interquartile range. Here, the graduates are less variable, hands down, and if we do look at the other number for standard deviation, which doesn't really apply here, but it's smaller in that case too. The fact that graduates vary less with respect to themselves as non-graduates too, that is also a stronger indication of less variability than we would have counter from the range being greater. So the answer is graduates are less variable, pretty definitively. Okay, what's next? Which distributions of debt are bell-shaped? Explain using details in the table to support your opinion. Be specific. Part of your grade will be how well you write this up. Well, graduates appear to be normal because the skewness and kurtosis are both between -1 and 1. So we've got, you see the skewness for the graduates is, you know, 0.22. The kurtosis is -0.5. That's between -1 and 1. And we also notice that the sample size is fairly high, so that's so we can be pretty happy with that sample size. For undergraduates, however, it does not appear to be bell-shaped. Kurtosis is less than -1, so that indicates flatness. And also, we only have a sample size of 10, so you know, we can't really tell if the data is bell-shaped or not from only 10 samples. Okay, so the last set of problems here has to do with, we're going to look at this cumulative percentage polygon for housing expenses, an ogive. And let's, just by this chart here, we should be able to answer these questions. What percent of residents pay more than $700 a month for housing expenses? Well, this chart is very handy here. We've got 700 a month starts right here. So what is the percentage to the right of 700 here? That's everybody here. Well, we have this cumulative percent polygon tells us that 700 a month, 20% of the 20% of the residents pay less than 700. They pay between 400 and 700, 20%. And that leaves 80% for above 700. So the answer is 80%. We look at 700, it's 20. This 20% is what's less than 700, and we want what's greater than 700. So the total of course is 100%. We want from 20% to 100%, which is all of the residents paying more than 700. 19. What is the median house payment? And explain how you obtained your estimate. Well, I would just go to 50% here, 50%, and I'd go over here and I'd see, oh, it's about that point right there. What is that point? That would be between 900 and 1,000. That looks like just halfway between 900 and 1,000, so I would call that 950. This is 900, 950, 1,000. That's the 50% point, so 950 is my answer. All right, what's next? These last three problems here, we're going to look at these box plots, these box and whisker plots here of total debt in 4 areas of the city. So we've got a southeast area, a southwest area, a northwest area, and a northeast area. And these are box plots which are nice and help us show median, range, interquartile range, and the range, and so on. So which area has the highest debt, highest central tendency for total debt? Okay, central tendency, that would be median. We're looking at the median here. And the median in a box plot is just the line, the vertical line in the middle. So we have Southeast looks like is the lowest. Southwest is next. Northwest is next, and northeast is the highest det. See, so the median is the highest. This is det down here. And so we have northeast because the center median point is the highest. It's right there. Okay, which area or areas has the lowest variability? Explain your answer. Okay, variability here is it can be measured by the total range, which is from the end of the whisker to the end of the whisker. That's a range. We can also look at this interquartile range here. These are the middle two quartiles. This may be an outlier. I mean, there can be, you know, just a few more here and then one way out here. So that's not and when the data is not normal, then, or even if the data is normal, the interquartile range is usually a better measure of variability. We see here that for range, this is the skinniest, or the least variable, and we see that the northwest would be the most variable if we're just looking at range. If we're looking at interquartile range, though, I think we'd see that the northwest is slightly less variable. It looks like it's the smallest, actually, if we're just looking at interquartile range. It would be between northwest and southwest if we're looking at interquartile range. If we're looking at complete range, northwest would be the would lose hands down, and southwest would win. Okay, so I state here that the southwest has the smallest range, and the southwest has the smallest range, and northwest has the smallest IQR. Some would argue that the IQR, okay, so this is range, not variability. Southwest has the smallest range, definitely has the smallest range. Northwest has the smallest IQR, which is this. Some would argue that the IQR being slightly smaller would imply lower variability, but I would accept either answer with your explanation. So if I were grading this, I would really accept either one of these answers, as long as you explain why. Range, well, you say the range is the smallest, and here you say the interquartile range is the smallest. And which distribution looks most skewed to the left, and why? And the southwest does, because we see the median is here. We see that the data to the left is spread out much more than the data to the right. So so that implies that it's skewed to the left. This is pretty much, this might be skewed a little bit to the right. This is pretty almost normal looking. This here looks like it's more data skewed to the right. So southwest is the answer, because the data left of the median is spread out much wider than data to the right. Okay, that completes a review of the example midterm. And so I'm going to end the video here, and the next video we will cover, I'm going to go over these two practice problem sets. And the last video, which is I think will be pretty helpful for you, I'm going to go over a couple of key problems here in our third problem set. So, thanks for watching.